In this video, I want to have a look at powers and roots. So we're going to start off by having a look at simplifying surds. So to simplify a surd, we're going to break the number down into factors, but we want one of those factors to be a square number. So if we have a look at our first example, if we've got the square root of 40, we can break that down, and we could break it down into lots of different pairs of factors, but we want one of them to be a square number. So we're going to break it down into 4 times 10, because 4 is a square number. So that's the same thing as going the square root of 4 times the square root of 10. And we know that the square root of 4 is 2, so that can be simplified down to 2 root 10. If we have a look at a second example, in this one we've got 3 root 150. So again, we want to break that 150 down into factors where one of them is a square number. So we're going to leave the 3 out the front, and we're going to break that into 25 times 6. So that can be broken into 3 square root 25 times square root of 6. And the square root of 25 is 5, so that will become 3 times 5 times the square root of 6, which will work out to give us a final answer of 15 square root 6. So that's how we can simplify our surds. Let's have a look at adding and subtracting surds. So the rule here is similar to algebra, that we can only add and subtract like surds, so they're terms with the same surd section. So if we have a look at our first example, we've got 2 root 5 plus 6 root 2 minus root 5 plus 10 root 2. So simplifying that, our like terms, we've got our 2 root 5 and our minus root 5. And we've got our 6 root 2 and our 10 root 2 there. So simplifying the 5s first, 2 root 5 minus root 5 will just leave us with 1 root 5, or just root 5. And 6 root 2 plus 10 root 2 will leave us with 16 root 2. We've added and subtracted the like surds. Sometimes we'll need to simplify it though. So our second example is the square root of 3 plus the square root of 12. So at the moment they're not like surds, but we can simplify that square root of 12. So we can have the square root of 3 plus the square root of 4 times 3, which will simplify down to 2 root 3. And now they are like surds, so we can add them together and we'd end up with 3 root 3. All right, our third example, we've got the square root of 90 minus 5 root 40 minus 2 root 10. So we're going to have to simplify everything that we can. The root 10 can't be simplified, so that's going to stay as is, but the square root of 40 and the square root of 90 can be. So that's going to become the square root of 9 times 10 minus 5 times the square root of 4 times 10 minus 2 root 10. Right, now the square root of 9 is 3, so that first term becomes 3 root 10. Square root of 4 is 2, so that's going to be 5 times 2 root 10. And then we've got a 2 root 10 there as well. Simplify that middle term one last time, and that will become minus 10 root 10. And we've got minus 2 root 10 on the end still. All right, now they're all like surds. Now we can go through and add and subtract. So we've got 3 minus 10 minus 2 would end up giving us minus 9 root 10. Lastly, I want to have a look at multiplying and dividing surds. So we've got a couple of rules here that we need to be aware of how they work. So if we had, for example, the square root of a times the square root of b, that's the same thing as having the square root of a times b. And we've been using the reverse of that rule when we were simplifying surds. If we had a root b times c root d, then we're going to multiply the numbers out the front, and we're going to multiply the numbers underneath their square root signs. If we had the square root of a times the square root of a, that would be the same as the square root of a squared, and it just gives us that a. And lastly, if we had the square root of a over b as a fraction, it's the same thing as taking the square root of the numerator divided by the square root of the denominator. So let's have a look at a few examples. Our first one is 4 root 2 times 5 root 18. So we're going to multiply the numbers at the front. So 4 times 5 would give us 20. and 2 times 18. So we multiply the numbers underneath, and that would give us 36. Then we can simplify because the square root of 36 is 6. So that would become 20 times 6, which would give us 120. Our second example, we have 10 square root 26 divided by 5 root 2. So we divide the numbers out the front. So we've got the 10 divided by 5 would give us 2. And then divide the numbers underneath the square root sign. So 26 divided by 2 would give us 2 root 13 as our answer. Third example, we have square root of 2 outside of square root of 5 plus the square root of 2. So we're going to expand this out. We're going to go root 2 times root 5 and then root 2 times root 2. So root 2 times root 5 would give us the square root of 10, and root 2 times root 2 would just give us 2. So that's the square root of 10 plus 2. All right, one last example. This one's a little bit longer. So if we had the square root of 5 plus 6 root 2 multiplied by 3 root 5 minus the square root of 3. So we're going to have to expand this out. So we're going to have the square root of 5 times 3 root 5 would give us 3 times 5, because the square root of 5 times square root of 5 is just 5. Then we're going to do the square root of 5 times the square root of 3 would give us minus, so that negative there, the square root of 15. Then we're going to have 6 root 2 times 3 root 5. So 3 6s are 18. So we're going to have 18 square root, and 2 times 5 is 10. And then our last one is the 6 root 2 times that minus root 3 would give us minus 6 root 6. So we can simplify this one out the front to give us a 15. We can't simplify the square root of 15 or 10 or 6, so that's just going to stay the way it is for the rest of it. So we're going to end up with 15 minus the square root of 15 plus 18 root 10 minus 6 root 6. Okay, so there's a few examples of how to work with surds.